All right, guys, limit notation for holes and vertical asymptotes. So in the last video, we talked a lot about these graphs and how to use limit notation for horizontal asymptotes and end behavior. But we haven't done that yet to talk about the limit notation for the coordinate point of the hole and where there's a vertical asymptote. All right, so on this graph, there's a hole when x is 1 and when y is 2. And our vertical asymptote passes through -2 on the x-axis. So that's going to be at x equals -2. Now, depending on the question, that might be how you answer it. Or we may have to answer as a limit. So with limit notation, we always have x approaching something, and then f of x is equal to something. All right, so we can basically just think of this as a coordinate point. All right, so whatever x is approaching, that's going to be our x coordinate. So here x is going to approach 1, and f of x means y, so y is just approaching 2. Now, why write it like this instead of this? Well, it's because on the graph, we never actually get to that point. That open circle is just telling us there's no graph right there. All right, so we approach the coordinate point 1, 2, but we never get there, which is why we write it as a limit. A limit is something that we approach, and you may or may not actually get to the point. In this case, we would not get to the point. Now, the vertical asymptote is tricky because to the left of the vertical asymptote, the graph is headed up, and to the right of the vertical asymptote, the graph is headed down. We actually have to split this into 2 different limit expressions. So it's going to look like this. We're still going to have that set up, so it's still going to be the limit as x approaches a number. In this case, the x coordinate is -2, but we're going to have to do this in 2 different ways. So the reason I'm putting -2 right here is that was what the x value was for the vertical asymptote. So I'm going to put those there. But because there's 2 different parts, we have to talk about as we approach -2 from the left and then differently, how do we approach it from the right? Okay, so I'm going to put a minus right here. So that tells us it's from the left, and a plus right there. That tells us it's from the right. Now, because this gets confusing, I'm just going to color code this a little bit. So this says to the left of -2. So the left of -2 is over here. I'm going to highlight this part. And we're going to give the value as we get closer to that vertical asymptote. Well, what's happening to our y coordinate? It's heading up. And so as we get closer to -2 from the left, the graph is going to approach a y value of infinity. Now, to the right of -2, that's what that plus stands for. To the right of -2, this is our graph here. As we get closer to -2, the graph is headed down, so the y coordinate that we're approaching is -infinity. All right, so that's it for this question. I do want to try one more type, though, and this is a little tricky, but we're going to try to sketch a graph given all this different information here. Okay, so first, this says the limit as x approaches -infinity is 2, and same thing as we approach positive infinity. And remember, that's left forever, right forever. So that always tells us the horizontal asymptote. So this is just saying there's a horizontal asymptote at y equals 2. All right, so right there is our horizontal asymptote. Now, for this course at least, anytime you see a one-sided limit, so either approaching from the left or the right, those are going to be our vertical asymptotes. Next year in calculus, that's not always the case. But for now, anytime you see that one-sided limit, we're going to draw ourselves a vertical asymptote. Now, we will come back to what it means. It's saying to the left of 3, we're approaching -infinity, and to the right of 3, we're approaching positive infinity. So we'll come back to that as we actually sketch the graph. But that just tells us we have a vertical asymptote at x equals 3. Now, lastly, it says the limit as x approaches 0 of our function is 1. So that means we're approaching a coordinate point at 0, 1. But here it says f of 0 is not 1. In other words, at 0, 1, there's not actually a point. It's not filled in. So this is telling us there's a hole at 0, 1. As we approach 0, we approach 1. But when we get to 0, there's not a y value of 1. There's no coordinate point there. So I'm going to put an open circle at 0, 1 to show that there's no point there, but we get close to that point. All right, so to fill out the rest of this graph, so to the left of 3, our y values are approaching negative infinity. So as we go this way, the graph is headed down. And to the right of 3, the graph is headed up. So over here, the graph is going to head up. Now, to finish the rest of this graph, the graph is just going to approach these asymptotes. So it's almost like it's kind of boxed into this section and boxed into this section. And so our graph is just going to pass through the x-axis, going to jump around the hole there because there's no point there. And then that just finished like that to the left. And the graph looks a little funky, but again, if it was smoother, that'd be a better graph. And then to the right here, it's kind of stuck in this section. So the graph is going to head towards that horizontal asymptote. All right. That's it. And we'll do some in class to kind of help. I know it's tricky at first when we draw these, but we'll get there. All right. Stay flawless.